Contravariance is similar to covariance. It gives you some additional flexibility with the generic type parameters, but contravariance works in the opposite direction. Let me demonstrate. I want a method that will allow me to add managers to the database. So I'll create a method called add managers. It takes an iRepository of employee, but what I really want to add into the repository is a new manager. And once I've added, I want to commit. And this is not a problem. An iRepository of employee, the add method takes an employee reference, and because manager derives from employee, it's not a problem to pass a manager where an employee is expected. So I could run this program and everything would work. But what if I want this method to only view this repository as something that can handle manager objects? Well, then I could say, I'll give you an iRepository of manager, but now I have a bit of a problem. This is where the C# compiler says, sorry, I cannot do that conversion for you. The method wants an iRepository of manager. This is only an iRepository of employee. I won't allow this to happen because, once again, iRepository, the T is invariant. If I have an iRepository of employee, I always have to treat it as an iRepository of employee. But this is where contravariance comes in. Contravariance uses the in modifier. And perhaps you can start to see the symmetry here. Covariance uses the generic modifier out, and T is used only as an output for the methods inside the interface. Contravariance uses the in modifier, and T is only used as an input for the methods inside. Except in this case, if I do a build, I have a bit of a problem because an iRepository is an iRead-only repository, and I'm declaring that T is contravariant, but the iRead-only repository interface is bringing in methods where T is used as a return value. And that could be bad. The purpose of contravariance is to allow me to use an I something of employee as an I something of manager, to use a more derived type there. And that's fine when the generic type parameter is used as an input, because an add method, if you want an employee and I pass you a manager, that shouldn't be a problem. But on outputs, contravariance there could lead to huge problems, because if I say, find me something from an iRead-only repository of manager, but it's really a repository of employee, and it's giving me back employee objects where I expect managers, that would be a problem. So for write operations, contravariance works, but I can't combine methods that take T as a parameter and return T and try to have any flexibility here. So the way I could do this, though, is to define another interface. Let me define an interface iWrite-only repository of T, where T is contravariant and this is also disposable. And I will take these methods from iRepository and paste them up here. And now it's not a problem making T contravariant because this interface does not inherit or use any other interfaces where T is used as a return type. In this interface definition, T is strictly just an input, so it can be contravariant. And now an iRepository has to remain invariant, but we can make it an iRead-only and an iWrite-only repository. iDisposable will get picked up from those two other interfaces. And now I should be able to do a build, and the C# compiler will be perfectly happy with the definitions that are in this file and how I'm using the in and out modifiers. I still just have a problem in the program because iRepository is invariant. But if I make this an iWrite-only repository, now I can build the program with no errors. And now I can run the program and see that we do indeed insert a total of 3 employee objects into the database, and one of them was a manager. And now you can see the symmetry from this side. I'm using covariance to take a type that uses employee and treat it as if it's using person, which makes sense because inside of dump people, I'm only reading from the interface, and I should be able to treat the employees I'm reading as people objects. And I'm using contravariance to treat a repository of employee as a repository of manager, because here I'm only writing to the interface, and the methods that require me to pass an employee should be able to take manager objects. That's the entire idea behind inheritance and object-oriented programming. And now I have read operations that return T in one interface definition where T can be covariant. Write operations that take T as a parameter are in another interface where T can be contravariant. And iRepository combines both interfaces to expose read and write capabilities, but T must remain invariant, which makes sense. Hopefully you can see why it would be bad to treat an iRepository of employee as an iRepository of manager in some circumstances. If I'm reading from that interface and expecting to get manager objects back, but only getting employee objects, that would be a problem. But if I'm only writing to the interface and providing inputs, well then managers are employees and things just work. And that is contravariance and covariance, not features you might use every day, but when writing a truly object-oriented solution to a problem and you're trying to reuse some processing code across an interface hierarchy, that's when you'll find these concepts and techniques useful.